Welcome to the second presentation of Descriptive Statistics, which focuses on tools we use to describe the center of distributions. Measurements that we make in a sample or in a population using either categorical or continuous scales are data. Data are communicated in distributions of one type or another, such as a frequency distribution or a cumulative distribution. And these distributions can be presented in many types of graphs and table. In any distribution of numbers, two of the most critical aspects are the central tendency of the distribution and the dispersion of the distribution. Central tendency means some way of characterizing the center of the distribution, and there are three primary measures of central tendency. The mode is the score or category that was most frequently received. The median is the score above or below which half the distribution falls. If the median of a distribution is 20, we know that half the participants receive that score or higher, and half receive that score or lower. The median is the 50th percentile rank of any distribution. The mean is the most important measure of central tendency for statistics. It is the arithmetic average of the distribution, and it is computed by adding all the scores in the distribution and dividing by the number of scores. Pay special attention to this formula, a sum divided by the number of data points. We will learn that many statistics we deal with are versions of this basic formula for the mean. Unlike the mode and median, the mean takes into consideration the numerical value of each data point. An extremely important property of the mean is that the sum of the difference between each score and the mean equals 0. Shortly, we will learn that a score minus the mean is a deviation score. Thus, the mean is the point in any distribution where the sum of deviations equals 0. Let's look at an example. Imagine a distribution of scores, say 10, 12, 13, 15, and 16. The mean would be the sum of those numbers divided by 5, or 13.2. If we then subtract the mean from each score, or compute the deviation for each score, and sum those deviations, they add to 0. The shape of the distribution affects the placement of the various measures of central tendency. In a symmetrical distribution, the measures of central tendency will equal each other. But in a positively skewed distribution, the mode will be lower than the median, and both will be lower than the mean. This pattern is reversed in a negatively skewed distribution in which the mean is lower than the median and both are lower than the mode. Because the mean is affected by every value of every data point in a distribution, it is pulled away from other measures of central tendency when there are many extreme scores. For example, the distribution of income in the United States is positively skewed. This means most individuals earn at the lower end of the income distribution while only a few achieve tremendous wealth. So the mean must move out to the positive tail in order to accommodate the extremely high incomes of those individuals. Because the mean then can be a distorted view of the center in a skewed distribution, statisticians will substitute the median as the primary measure of central tendency at times. For example, most reports of income in the United States focus on the median income, or you will most often hear about the median home price in a community. The scale of measure used by researchers affects the central tendency they can compute. A mode can be computed in any scale of measure, but a median and mean cannot be computed for a nominal scale. A median can be computed for an ordinal scale and for interval or ratio scales, but a mean cannot be computed for an ordinal scale. Thus, we cannot compute the average socioeconomic status for participants when that variable is scored using an ordinal scale, such as lower, middle, and upper classes. A mean can be computed only for interval or ratio scales of measure. As we look at how scales are actually used in research, we will find that many researchers will assume there is no substantive difference between their ordinal Likert type scales and an interval scale. When they can make this assumption, they will then be able to compute a mean score and use the statistics that are appropriate for the mean, such as the parametric statistics we will focus on in this class.